Look around you right now. Think about the phone or computer you are using. Think about the desk you are leaning on, the water in your bottle, and even the air you breathe. Everything in our environment has a purpose. In geography, we use a very specific word for anything that satisfies our human needs. We call it a resource, but a resource is not just any random object we find in nature. To be classified as a true resource, an object must meet 3 strict conditions. First, it must be technologically accessible. This means we must possess the tools and knowledge to extract and use it. Second, it must be economically feasible. This means we must be able to afford the extraction process without going bankrupt. Third, it must be culturally acceptable. This means our society must agree that using it is right and proper. When these 3 conditions are met, raw material is transformed into a resource. In this chapter, we will learn how resources shape our daily lives. We will look at how human activities classify, plan, and sometimes abuse these resources. We will see how our actions affect the planet, from global warming to soil degradation. Most importantly, we will discover how we can save our world through smart planning and conservation. Let us break down what a resource really is. A resource is anything in our environment that helps us survive and thrive. But nature does not just hand these items to us on a silver platter. Human beings play an active, vital role in creating resources. We interact with nature using technology. Then we create institutions, like businesses, laws, and universities, to manage and distribute what we produce. Think of crude oil trapped deep under the ocean floor. Millions of years ago, it was just thick, black sludge. It was not a resource because humans had no idea it existed, let alone how to use it. Once we developed advanced drilling technology, that sludge was transformed into black gold. We built refineries and global markets to process and sell it. Technology and human action transformed raw nature into a resource. This interactive relationship is represented as a triangle. Nature is at the top, technology is on one side, and institutions are on the other. Human beings stand in the very center of this triangle. We connect these elements together. We take materials from nature, apply technology, and create institutions to accelerate our economic development. This means that human beings are the most important resource of all. We find raw materials, apply our minds, and make them useful. Without human intelligence, the richest mineral deposits are just useless piles of rock. We are the active link that connects nature, technology, and institutions. Geographers group resources into different categories to understand them better. First, we look at their origin. Biotic resources come from living things or organic matter. Forests, wild animals, fish, crops, and livestock are all biotic. Abiotic resources come from non-living things. Rocks, metals, air, and water are all abiotic. This is the simplest way to divide our physical world. Second, we classify them by exhaustibility. Renewable resources can replenish themselves naturally over time. Solar energy, wind power, and water flow are excellent examples. Non-renewable resources take millions of years to form deep within the earth. Coal, petroleum, and natural gas are non-renewable. Once we burn a lump of coal, it is gone forever. Third, we look at ownership. Individual resources are owned by private people, like your family house, a farmland, or a personal vehicle. Community resources are shared by everyone in an area, like public parks, village ponds, or grazing grounds. National resources belong to the entire country. This includes all land, forests, and minerals, as well as the ocean area up to 12 nautical miles from the coast. 12 nautical miles is about 22 kilometers. International resources are open to all nations under global laws. The open ocean, beyond 200 nautical miles from any country, is international water. No single country can use these resources without permission from global institutions. The International Seabed Authority is one such group that controls these areas. Finally, we group resources by their status of development. Potential resources exist in a region, but are not being utilized yet. Rajasthan and Gujarat have massive potential for solar and wind power, but we have not set up enough plants. Developed resources are fully surveyed, and we are actively using them today. We also have stock and reserves. Stock refers to materials we want to use, but we lack the technology to do so. For example, water contains hydrogen, which is a massive energy source, but we do not have the technology to extract it cheaply yet. Reserves are a subset of stock that we can use with current technology, but we are saving them for future emergencies. For a long time, humans believed resources were free gifts of nature. This assumption led to reckless, greedy behavior. We began using resources indiscriminately, which created three massive global problems. First, we are depleting resources rapidly just to satisfy the greed of a few wealthy individuals. Think of how ancient rainforests are cleared just to make luxury wood furniture. Second, resources are accumulating in only a few hands. This divides our society into two distinct segments, the haves and the have-nots. It creates a massive, unfair gap between the rich and the poor. Third, our greed has triggered global ecological crises. Global warming, ozone layer depletion, environmental pollution, and land degradation are proof of this. We are burning fossil fuels and destroying forests at a speed the Earth cannot handle. These ecological problems affect everyone, not just the people who cause them. Rising sea levels threaten coastal cities. Extreme weather patterns disrupt farming and food supply. An equitable distribution of resources is no longer just a nice idea. It is now essential for the survival and peace of our planet. To solve these crises, we must practice sustainable development. This means development should take place without damaging the environment. More importantly, development in the present must not compromise the needs of future generations. It is like spending the interest on a bank account while keeping the main savings untouched. In June 1992, world leaders realized they had to act. More than 100 heads of state met in Rio de Janeiro, Brazil. This was the first International Earth Summit. The summit was called to address urgent issues like climate change and biodiversity loss. The leaders signed a historic declaration to combat environmental damage, poverty, and disease. This plan is known as Agenda 21. It is a global blueprint for sustainable development in the 21st century. It promotes global cooperation based on common interests and shared responsibilities. One major goal of Agenda 21 is that every local government should create its own local plan. This is called a Local Agenda 21. It teaches us that saving the Earth starts in our own towns and neighborhoods. By taking local actions, we can solve global environmental problems. India is a vast country with enormous diversity. Some regions are rich in certain resources, but completely lack others. This makes balanced resource planning essential for our nation. Let us look at some examples. The states of Jharkhand, Chhattisgarh, and Madhya Pradesh are rich in coal and minerals. However, they lag in infrastructure and economic development. Arunachal Pradesh has an abundance of water resources, but it lacks developed roads, schools, and hospitals. Rajasthan is blessed with solar and wind energy, but it has an acute shortage of water. Even the cold desert of Ladakh is isolated. It has a rich cultural heritage, but it lacks water, infrastructure, and vital minerals. This uneven distribution can lead to tension between different states. Balanced resource planning ensures that all regions develop equally. To balance these differences, India uses a three-step planning process. First, we identify and map resources across the country. This involves surveying, mapping, and measuring resources. Second, we build a planning structure with the right technology, skills, and institutions. Third, we match resource development plans with our overall national goals. Having resources is not enough. You must use them wisely. Irrational consumption and overutilization lead to severe socioeconomic and environmental problems. Throughout history, great thinkers have warned us about this. Mahatma Gandhi spoke clearly about resource conservation. He once said, "There is enough for everybody's need, but not for anybody's greed." Gandhi believed that selfish individuals and modern, exploitative technology were the root causes of global depletion. He was against mass factory production. Instead, he wanted production by the masses. In 1968, a group of thinkers called the Club of Rome advocated for systematic conservation. Later, in 1974, E.F. Schumacher wrote a famous book called Small is Beautiful, which echoed Gandhian ideas. Finally, the Brundtland Commission report of 1987 introduced the formal concept of sustainable development to the world. This report was published as a book called Our Common Future. History shows us that resource-rich regions are often targets for invasion. Colonizing countries use their superior technology to exploit the resources of other lands. This established their global supremacy. India experienced this during British rule. Therefore, resource conservation is also about protecting our national independence and future security. We live on land, we work on land, and we build on land. It is our most vital natural asset. Land supports wildlife, human life, forests, and transport systems. But land is finite. We cannot create more of it. India is blessed with a variety of relief features. About 43% of our land consists of plains. These plains are perfect for agriculture and industry. Mountains account for 30% of our total surface area. They ensure the perennial flow of major rivers, promote tourism, and protect our ecology. Plateaus make up the remaining 27% of the country. These plateaus contain rich reserves of minerals, fossil fuels, and dense forests. We categorize land based on how we use it. We have forests, land not available for cultivation, pastures, fallow land, and net sown area. Land use data in India is available for 93% of our total area. Some border regions are not surveyed yet. Net sown area is the actual physical land where crops are grown and harvested. In India, net sown area is about 54% of the total reporting area. Humans have shared the land with past generations, and we must pass it to the future. 95% of our basic needs for food, shelter, and clothing come from the land. Yet our actions are damaging it. Land degradation is a growing threat. Different states in India face different degradation challenges. In Jharkhand, Chhattisgarh, Madhya Pradesh, and Odisha, mining has left deep scars on the landscape. Deforestation for mining has ruined the soil. In Gujarat, Rajasthan, Madhya Pradesh, and Maharashtra, overgrazing by cattle is the main cause of damage. Meanwhile, in Punjab, Haryana, and western Uttar Pradesh, the problem is over-irrigation. Excessive watering leads to waterlogging. Waterlogging increases the salinity and alkalinity of the soil, making it infertile. In other areas, industrial dust from grinding limestone coats the ground, stopping water from sinking in. To save our soil, we must practice afforestation and manage grazing lands. We must plant shelter belts of trees and stabilize sand dunes with thorny bushes. Finally, we must treat and dispose of industrial waste properly. These steps protect both our land and water resources. Soil is the most important renewable natural resource. It supports plant growth and sustains living organisms on Earth. But soil is not just dead dirt, it is a living system. It takes millions of years to form just a few centimeters of topsoil. Soil formation is a complex process. It depends on relief, parent rock, climate, vegetation, and time. Natural forces like temperature changes, running water, wind, and decomposers work together constantly. They break down rocks into tiny particles. Soil consists of both organic matter, which we call humus, and inorganic materials like sand, silt, and clay. Chemical and organic changes happen in the soil constantly. Climate determines the rate of weathering and soil formation. Understanding soil chemistry is the key to successful farming and environmental balance. India has varied landforms and climates, which have created 6 distinct types of soil. The first is alluvial soil. This is the most fertile and widely spread soil in India. The entire northern plains are made of alluvial soil, deposited by the Indus, Ganga, and Brahmaputra rivers. It is rich in potash, phosphoric acid, and lime. It is ideal for growing wheat, paddy, and sugarcane. Alluvial soil is classified by age as Bangar and Kadar. Bangar is old alluvial soil with more Kankar nodules. Kadar is new alluvial soil, which is fine and highly fertile. The second is black soil, also known as Rigur or black cotton soil. It is perfect for growing cotton. This soil is typical of the Deccan Plateau region. It is clayey and holds moisture well, but it develops deep cracks in hot weather. The third is red and yellow soil, which develops on crystalline igneous rocks in low rainfall areas. Diffusion of iron gives it a red color, and it looks yellow when wet. The fourth is laterite soil, derived from the Latin word meaning brick. It forms in tropical climates with heavy rains, causing intense leaching. It is acidic and perfect for tea, coffee, and cashew nuts. The fifth is arid soil, which ranges from red to brown. It is sandy and highly saline. The lower layers are filled with chancre nodules, which restrict water from filtering down. The sixth is forest soil, found in rainforests and mountains. It is loamy in valley sides, but coarse and acidic in high, snow-covered slopes. The washing away of topsoil by water and wind is called soil erosion. Soil formation and soil erosion usually happen at the same time, maintaining a natural balance. However, human activities like deforestation, overgrazing, construction, and mining disturb this balance. Water causes distinct types of erosion. Running water cuts through clayey soils, carving deep channels called gullies. This makes the land useless for farming, creating badlands or ravines. In the Chambal Basin, these badlands are called ravines. Sometimes, water flows as a giant sheet down a slope, washing away the entire top layer. This is called sheet erosion. Wind also blows loose soil off flat lands, which is wind erosion. Fortunately, we can check erosion with smart farming. Plowing along contour lines, known as contour plowing, slows down water flow. Cutting steps into hillsides, which is terrace farming, restricts soil loss. We can also leave strips of grass between crops, a method called strip cropping, to break the wind. Finally, planting rows of trees as shelter belts stabilizes sand dunes and stops deserts from expanding. Resources are the foundation of human survival and economic growth. However, our indiscriminate exploitation of these assets has caused severe ecological damage and social divide. To protect our future, we must implement balanced resource planning and sustainable development. By understanding our diverse land and soil systems, we can conserve these vital lifelines for generations to come.